These notes are going to cover the notes over direct variation. So direct variation is actually a special type of linear equation. It's going to feel kind of unrelated to all the other forms that we've learned already, but it is a type of line, so we do learn it as well. Okay, so our essential question is, how can I tell when an equation, table, or graph represents direct variation? So it is really important that you guys are able to say either yes or no to this question, and so you're going to do the check to see if that constant of variation is there or if it does represent that, and I'll show you guys how to do that as well. So this is our last lesson in Unit 3. So direct variation is a special kind of linear equation, so it still creates a line, but it goes through the origin, and that is also known as the point 0, 0. So it goes through the origin. So you'll see that the lines that we've done in the past, they don't always go through 0, 0. You'll see that there's lines that go through, the y-axis at 3, so it definitely doesn't go through 0, 0. So direct variation equations always go through 0, 0. Now the equation for direct variation is y equals kx. Now just like all of the other linear equations we've done, all the forms that we've done, they all have an x and y in them. So go ahead and remind you of the past 3 we've learned. Y minus y1 equals m times x minus x1. That's point slope. Y equals mx plus b. That's slope-intercept. And standard form is ax plus by equals c. So in all 3 forms, we have a y and an x, a y and an x, a y and an x. So every type of linear equation that we have written so far, from a point or from a slope or whatever we have and we're given, we always have an x and a y in our equation. And the same thing happens here. You're going to have a y and an x. It's just that we've now introduced a new variable, which is k. So, when you guys write an equation, when they ask you to write an equation of direct variation, you make sure that you have a y and an x in your final equation. Now, the constant of variation is the letter k. So that k there is kind of like a slope, but not really. Remember, slope is represented by the letter m. And so this kind of looks like y equals mx plus b, sort of. Except instead of an m, there's a k, and then your b is technically 0 because your y-intercept is always 0 because it goes through the origin. But you don't have to worry about all that. So your constant of variation is also known as your k. It is not the same thing as slope, so when they ask you to find if it's direct variation, do not find the slope. That's not what they're asking you to do. All right, so to calculate k, so we're going to use some knowledge from Unit 1 here where we solve a literal equation. So if I'm asked to calculate the constant of variation, k, also, it's not going to call it the letter k. You're going to have to know what constant of variation means. So the constant of variation is the letter k. Just like how slope is m, and the b is a y-intercept, k is the constant of variation. So we want to calculate for k, so we want to get k by itself. So in order to get k by itself, we've got to get rid of the x that's attached to it. Well, k and x are connected by multiplication, so I would divide both sides by x. Okay, so those x's go away, and I have y divided by x equals k. This is the formula to how to find k. So it's y divided by x. Kind of like slope. In slope formula, what variable goes on top? The y goes on top. So it's very similar to finding slope, but not the same. So it's completely different, but it's similar. Okay, so don't get the two mixed up. It's not slope. Remember, slope is m, and constant variation is k. So this formula is really important because we do need to know it to solve for k. Okay, so a table represents direct variation if k is constant. So you're going to get problems that are saying, hey, determine if the representation represents direct variation. And the way you determine that is you calculate k. You want to see if k is constant here. So what you want to do is you want to go with each ordered pair. Okay, so we're going to do the first ordered pair. Now remember, the formula to calculate for k is... Remember, k is y divided by x, and we got that formula on the last page. K equals y divided by x. That's the formula. So to calculate the k here, okay, oops, sorry, that was not meant to be a pun, but I guess it technically was. Y divided by x, that's 4 divided by 12. The y value goes on top, the x value goes on the bottom. You simplify that down, you got 1/3. So our k value for our first ordered pair is 1/3. Then we move on to the next ordered pair, 9, 3. Well, k calculating here is still going to be y divided by x, so 3 divided by 9. That also simplifies down to 1/3. Let's move on to the next point, 6, 2. Well, to calculate k, that's going to be y divided by x. So your y here is 2, x is 6. 2, 6 simplifies down to 1/3. And then our last point is 1 divided by 3 here, so k equals 1/3. Which is still equals 1/3, so that doesn't simplify down to anything. Now, what do you notice about your k value in each ordered pair? They're all the same. So was k constant? Remember, constant means the same. Was k constant in every single ordered pair? Yes. So because it is yes, then this does represent direct variation. So your answer here would be yes, it does. It does represent direct variation. If it is yes, what's the equation? So this 1/3 is not the equation. The 1/3 is your k value. So that's your k, but what's the equation? Well, remember that direct variation looks like y equals kx. You just solved for k. K is 1/3. Okay, so you just plug in 1/3 there. So your equation here is y equals 1/3 x. Now, remember, in your equation, what two variables should you have left over? A y and an x. And we do. There's a y here and there's an x here. And you should always have a y and an x in your equation that you write. All you're doing is you're solving for that k and you're plugging it in. Kind of like if I gave you y equals mx plus b. I told you the m is -2 and the b is +5. Then you would just plug in y equals -2x plus 5. So basically you're solving for the k value, and once you find that k value, you can just plug it into the equation. Number 2, we're going to see if this represents direct variation. So same thing, you're going to calculate for k here. So we're going to do the first ordered pair first. Remember, the formula for finding k is y divided by x. So it's going to be 3.2 divided by -2. Now, because this table did give us decimals, we are safe to keep everything as decimals. So this is going to give us -1.6. And then we move on to the next point, or next ordered pair, is 1, 2.4. We're going to calculate k, that's y divided by x, so 2.4 divided by 1, which just simplifies to 2.4. Well, what do you notice already? These two numbers are not the same. So do I even need to keep going? No, because it needs to be constant for every ordered pair. As soon as you find that it's not constant, you don't have to keep going. So is this direct variation? No. And why was it no? Well, because your k is not constant. It has to be constant to be direct variation. So the answer is no, and if it's no, can you write an equation? You can't write an equation. So if it's no, there is no equation. Don't put an equation. People have put an equation before. I don't know why, but if it's no, you can't create something from something that isn't there. So this is no. This is not direct variation. Whereas number 1, it is, because when you calculate your k for each ordered pair, it is constant. All right, moving on to the next section. An equation represents direct variation if it looks like y equals kx. Now remember, that's the formula for direct variation. That's the form. We want y equals kx. Remember, we want our y-intercept to be 0, 0. And why is that? Remember, direct variation goes through the origin. It goes through 0, 0. So let me go ahead and kind of show you what I mean by it has to go through 0, 0. So y equals 3x. This is direct variation, and here's why. Your k here is 3, not the slope, okay? This is not the same thing as slope-intercept form. This is not the slope. You can kind of think about it like the slope, but it's not slope. So 3 is your k here, and then your y-intercept is 0 because it's plus 0. So you'll notice if I click on the origin, that's where it goes through. It goes through the origin. Whereas if I have like y equals 3x plus 2, for example, that's not direct variation, and here's why. It does not go through the point 0, 0. 0, 0 is down here, and it does not go through that. So this blue equation is not direct variation. So how do I tell something is or something isn't? You want the y-intercept to be 0. If the y-intercept is 0, it is direct variation. If the y-intercept's not 0, then it's not direct variation. So here you saw that the y-intercept was 2, it's not, but the red one it is because it goes through 0, 0, and the other one doesn't go through 0, 0. Okay, so let's go ahead and do that. We want it to look like y equals kx, so you want to get that y by itself. We're trying to get y by itself to see what the y-intercept is. So we basically want it in slope-intercept form. We want it in y equals mx plus b. So starting with number 1, 7y equals 2x. We want to get that y by itself. Well, to get y by itself, we've got to get rid of the 7, so we're going to divide both sides by 7. Well, 7 divided by 7 cancels and becomes 1. So this is 1y equals. And then remember, we want to write that 2 over 7 as a separate number. So 2/7 and then an x next to it. Okay, so the question is this direct variation? Does it look like y equals kx? Well, first of all, let me ask you, what's your k value here? Your k value here is 2/7. So the k value is 2/7. And then what's your y-intercept? 0, 0. Right? Because there's technically an imaginary 0 right here, right? So if your y-intercept 0, 0, is this direct variation? Yes. So go ahead and we're going to box our equation, and we're going to say yes, it is. because the y-intercept is 0, 0. You want it to go through 0, 0. And you'll see an example where it's not eventually. Number 2, 3y plus 4x equals 8. Again, the goal is you want to see if it's direct variation, so you got to get y by itself. So to get y by itself, the first step I would have to do here is subtract both sides by 4x. Okay? And we have 3y equals 8 minus 4x. Those are not like terms, so you cannot combine them with each other. Our next step here is we still want to get y by itself, and it's not quite there yet. We got to get rid of the 3, so we're going to divide everything by 3. 3 divided by 3 becomes 1, so that's 1y equals 8 divided by 3 does not simplify, so it stays 8 over 3 minus 4 over 3. That doesn't simplify, so that stays negative 4 over 3x. So now we have an equation. So let's go ahead and identify some stuff. What's your k value here? Remember, the k value is attached to x here. Your k value is negative 4/3. And what's your b value? What's your y-intercept? It's 0, 8 over 3. Is that y-intercept 0, 0? No, it is not. So this is no, it is not direct variation. Okay, it would be no here. That's our answer, not direct variation. Because the question is, well, it doesn't really ask you a question, but they're telling you equation is direct variation if it looks like y equals kx. So you determine is yes, it is, or no, it's not. And obviously, if it's not, then technically there is no k value. So really, we're just looking at the y-intercept here. All right, moving on to number 3. Remember, goal is you want to get y by itself. So the first thing I'm going to do is subtract that 4 over. So subtract 4 from both sides. And remember, you can only subtract from like terms, so you've got to subtract from the negative 5. 3y equals 5x. Negative 5 minus 4 is negative 9. And then you do what? Oh, that was not English. You want to divide everything by 3 to get rid of the 3 in front of the y. So y equals 5/3 x. And then negative 9 divided by 3 is negative 3. So then you want to look at your y-intercept. Remember, that y-intercept is going to tell us if it's going to go through the origin or not. Well, what's your b value here? It's 0, negative 3. That's your y-intercept. So is that 0, 0? Nope. So this is also no. Okay, so no, it is not direct variation. Moving on to number 4. Okay, first step I'm going to do is try to get y by itself. Now, y is on the right-hand side this time. So I'm not going to move it because the goal is to get y by itself, so I don't really need to move it. I just need to move the stuff around it. So the first thing I'm going to move on this side is subtract that 4 over. So I'm going to get rid of this 4, so it's going to go away. And then over here I have 4 minus 4, and that's also 0, so that goes away as well. So then I have 10x equals 3y. Well, my next step here is still to get y by itself, and I'm going to divide by 3 again. A lot of dividing by 3's. Remember, y by itself, not x. We want y by itself because you want the equation to be y equals. Divide that by 3. We have y equals, well, 10 divided by 3 is just 10/3 x. So obviously this is written in a backwards order, but if you wanted to rearrange it, you could. It's y equals 10/3 x. That's the same exact thing. So my question to you is, what's your y-intercept this time? This time it's 0, 0. And here I'll reorder it so that's a little easier. Y equals 10/3 x. Remember, there's technically a plus 0 here because they didn't add anything. There's no number there, so that y-intercept is 0. So it is direct variation, so we say yes here. And then we'll go ahead and box our equation as well because it is direct variation. Okay, moving on. Now, here are the types of problems that you'll see more like on a STAR test. And they're kind of problems that you've seen them before. You can technically do them another way. You could technically use proportions to solve them, but we're going to solve it just using the direct variation equation. So the first thing is, anytime we have a word problem or anytime there's words involved, things can get a little tricky. So it's really important that you're able to pick out the things that you need and set up the equation properly. Because it's really easy to set it up wrong because you just plug the numbers in wrong and anywhere that you'd like almost. So you don't want to do that. All right, so the trick is, it's the way it's written. It says y varies directly with x. Now, you'll know a problem is direct variation when it says varies directly or like directly proportional or something of that nature where it says directly in there. You'll know that you'll be talking about direct variation. Now, you don't use direct variation, y equals kx. You don't use this whenever you want. Like, you only use it for direct variation problems. So like, if I'm asking you to write a problem in point slope form, like this should not be popping into your head at all. Okay. So it's all in the wording. If it says y varies directly, that's how I know it's direct variation, y varies directly with x, then that equation is going to be y equals kx. Whatever variable comes first in the equation. So y comes first in the equation, and then it says it varies directly, which is the k part. with x, and x comes second or the last in the equation. So you're kind of reading it left to right. So let's go ahead and translate the second one. P varies directly with C. P varies directly with C. Okay, P comes first. P varies directly, so equals K with C, and C is going to be here. So P equals K, C. So whatever letter comes first is a letter that comes first in your equation. You don't have to use P and C if you don't want to. Usually it uses X and Y, but I just kind of wanted you to see how it's written in word problems. So, because you're going to get word problems and they're not going to be super obvious. All right, so number one, if Y varies directly with X, okay, that's a be like, hey, like this is direct variation. Why is it direct variation? Because it says varies directly in the problem. So if you see varies directly or direct variation, your brain should switch to, okay, I need to think of Y equals KX. No more slope, no more point slope, no more standard form, Y equals KX. If Y varies directly with X, and Y is 16 when X is 4, what is Y when X is negative 2? Okay, that's a lot of stuff, right? So let's set up what we know. Y varies directly with X. Okay. So Y comes first, so this is Y varies directly, so equals K with X, so Y equals KX. So this is the normal equation we've been working with, so this is not anything new to us. All right, that's our equation for direct variation. Okay, then they're giving us some information. It says when Y is 36, X is 4. Okay, so when Y, oops, maybe I need to make this a little larger. When Y is 36, X is 4. So let's go ahead and write that down. When Y is 36, X is 4. Okay, so they're giving us some information there because we don't know what our K value is, right? Like we have no idea what K is. So we need to solve for K first. So first we're going to solve for K. Well, this is the equation that they've given me. I need to solve for K. Well, how do I solve for K? What's the formula to solve for K? Well, to solve for K, isn't that Y divided by X on the very first page? So it's going to be 36 divided by 4, which is 9. So K equals 9. But that's not my answer. They didn't ask me to find K. And remember, K represents what again? Constant of variation. They did not ask me to find the constant of variation. They asked me to solve for a different number. So let's go ahead and write what our equation would be. If K equals 9, then what's the equation here? Then your equation is Y equals 9X. Okay? So it's kind of like solving for slope. Once you know the slope, you kind of plug the slope in. So we solved for K, and we're plugging it into this K here. This is kind of weird, I know. All right, this is your equation, but it's not your answer. Okay? Because next they want you to solve for something. They said, what is Y? So they want you to solve for Y. What is Y when X is negative 2? So solve for Y when X is negative 2. So now we know that Y is what? Question mark? And X is negative 2. So we're going to use the equation we just made to solve for that. So we have Y equals 9, and then we're going to plug in negative 2 for X because it says X equals negative 2. So negative 2 here. So we get Y equals, what is that going to be? Negative 18. So Y equals negative 18. Now let's talk about what did they want us to solve for. What did they want us to find in the very end? They wanted to know what is Y. Did we solve for Y? Yes, we did. So this is our final answer. Okay, so this is basically taking the bits of information they've given you, finding that K value, then finding the equation, and then solving. So here's the steps. Find the K value, so find the constant of variation. Step 2, write the direct variation equation. I'll go ahead and put colon here. Here we go. And then the last step is solve for the variable, I guess. Solve for variable. There we go. Okay. All right, so you have 3 steps basically is what you're going through each time. All right. Oops. All right. right, moving on to number 2. Suppose y is directly proportional to x. Now again, it doesn't say varies directly, but it does say directly proportional. And anytime you see varies directly or directly proportional, you know it's direct variation. That word directly kind of tips that off to us. So this is directly proportional. Now what letter came first? It says y is directly proportional with x. So it's going to be y first, directly proportional equals k to x. And then we have an x here, so y equals kx. Okay, then it says x is 12 and y equals 6. So x equals 12 and y equals 6. The last thing they want us to do is find the equation that relates to x and y. Find the equation that relates x and y, Find the equation that relates x and y. Basically, they want you to find the direct variation equation that has an x and y in it, which means when you finish this, you should have an x and y in your equation, and if you don't, you've messed up. All right, so let's go ahead and write down what we've given. We got the direct proportion part. Let's do the red part. It says x is 12 when y equals 6. The first step is you got to solve for k. Just like how when we don't have our slope, we got to solve for the slope. If they don't give us a constant of variation, we got to solve for the constant of variation. So first thing I'm going to do is calculate k. Remember, k is y divided by x. So in this case, that's going to be 6 divided by 12, which is going to be 1/2. Okay, that's our k value. Okay, well then that's our equation then. Well, our equation is going to be y equals 1/2 x. So then the main thing is, what do they want us to find? Find the equation that relates to x and y. Did you find an equation that relates x and y to each other? Yeah, because your final equation has an x and y in it, and you're done. Like, you found the direct variation equation here. That's all you have to do. I need to write this a little bit bigger. It's like super small. Y equals 1/2. Oops, I'm selecting the wrong colors. X. And that is your equation, and you're done. Now, why did you have to do more work in the last problem? Well, in the last problem, they didn't ask for an equation. They asked you to solve for something completely separate. So you still needed the equation to find this next number, but, you still need to do the equation to find the next number, but you didn't necessarily need to just only write an equation. So this one, they just want you to write an equation. Could you use it to find something else? Yes, you could. And then now it asks you, find the value of x when y equals 4. So now they want you to use the equation. Find the value of x. So find x when y equals 4. So that means, this is what we know. X is question mark. Find x when y equals 4. Well, using the equation that we just created, y equals 1/2 x, we're going to solve this equation. Well, we're going to plug in 4 for y because that's all we know. So 4 goes here, equals 1/2 x. Okay, so what you want to do next is you want to try to get x by itself. So I'm going to divide both sides by 1/2. I'm trying to figure out what color to use. We'll use pink. Divide both sides by 1/2. Or you can multiply both sides by 2, technically. That would get rid of the 1/2. So this would be x equals, now 4 divided by half is the same thing as 4 times 2. So it's going to be 8. I know that seems kind of weird, but I can explain to you if you're really curious. But 4 divided by a half is 8. 4 times a half is 2. 4 divided by a half is 8. So it's actually doubling. So did we answer the question? Did we find x when y was 4? Yes, we solved for the value of x. All right, and then our last question here is choose the amount of money. Sorry, not choose. The amount of money raised varies directly with the number of people at the fundraiser. The money raised for 5 people was $100. How many people will be needed to raise $4,000? Okay, this one causes a lot of issues because, again, it's a word problem. It's a word problem, so it's like, oh, crap, like, what do I do? All right, we're going to answer one of these at a time. So the main question is, how many people will be needed to raise $4,000? Like, that is the big question we should be able to answer at the very end. So we want to know the answer to that, okay? So we're first going to decipher all the information we've been given. So it says, the amount of money raised varies directly with the number of people at a fundraiser. How do I know this is a direct variation problem? Because it gives me the keywords varies directly. Anytime I see varies directly or directly proportional, always be like, okay, y equals kx, y equals kx. All right, now what comes first in that sentence? Because they do not use variables for you. They don't use variables. They use words. So I will do this I'll show you 2 different ways. If you want to use y and x, we can. So we'll use y and x because that'll be a lot easier. So we'll do that. Okay, so the amount of money raised, that comes first. The amount of money raised comes first. So that's going to be our y. Y always comes first. Y varies directly with x. Well, it says the amount of money raised varies directly with the number of people. Okay, well, the number of people is going to be our x. So the amount of money raised, y, varies directly with the number of people, x. So I'm going to go ahead and write that first. So y is going to be the money raised, and x is the number of people. Now, how do I know y is the money raised? Because that came first. Whatever comes first in the sentence is always y. Just like here, it says y is directly proportional to x. Y comes first. Okay, so we got that part. And then it says money raised for 5 people was $100. For 5 people was $100. Okay, that's important. So first, we got to figure out the constant of variation. Now, what variable represents constant of variation again? That's the letter k. Well, how do you solve for k? Well, to solve for k, that's going to be y divided by x, right? Actually, I'm going to do that down here. Solve for k, it's going to be y divided by x. All right, well, we got to figure out if they gave us a y and an x. Well, they didn't give us any numbers except for one pair of numbers. The money raised for 5 people was $100. So then I got to figure out people and dollars. Which one of those is x? Is 5 people x or is it y? 5 is your x. So it says x is 5 people. And then how much money? Money is y, and they raised $100. So this is $100 here, okay? So to solve for k, we're going to do y divided by x. So it's going to be 100 divided by 5, which simplifies down to 20. So for constant of variation, we're going to answer that with 20. K value is 20 here. Okay, the next thing we're going to do is we're going to solve for get the equation. Well, the direct variation equation is y equals kx. Well, do I know what k is? Yeah, I just solved for it. So the direct variation equation would be y equals 20x. Okay, so that's the equation. Wow, why is that written so small? I've been writing it really small lately, and it kind of bothers me from when I zoom out, because I'm like, wow, why is it so tiny? Y equals 20x. That's our equation. That's it. That's all you have to do. The next part is the solution, the answer to the big question. How many people will be needed to raise $4,000? So, using this equation, we're going to answer that question. How many people will be needed to raise $4,000? So, X is people, right? But we don't know how many people. Y is money, and the money is 4,000. Okay, we don't know X, but we know Y, right? We know what the Y is. We want to raise $4,000. We got to solve for how many people that would take. So using the equation we just got, Y equals 20x. We're going to plug in the information we know. Okay, we're going to plug in 4,000 for what variable, X or Y? We're going to plug it in for Y. So 4,000, equals 20x. Well, we want to get x by itself, so the next thing I would do here is divide both sides by 20. And then x equals 4,000 divided by 20 is going to give me 200. Now, that's an answer, but we're talking about word problems here. So what is the meaning of that answer? What does x represent in our problem? X represents people. So this would be 200 people. So in order to raise $4,000, you need to have 200 people. So it seems like a really complicated way to do things, but I know it's just kind of weird. It's just direct variation, but it's just seems really more complicated than it needs to be. But basically, you got to decipher everything and then translate that into math. So this problem requires a lot of thinking power, but the steps are: you want to find the constant first, find k, then get the equation set up. Once you found k, the equation's easy because you just plug k in for whatever k is, and then you use the equation to solve for what you want. And usually you use the numbers that they give you to solve for it. So that is it for direct variation. If you have any questions, please feel free to let me know.